The whole world is up for grabs right now with respect to data. So notes Houseware co founder Divyansh Saini, whose technology gives business users direct access to data driven metrics in Snowflake. And when they say metrics, they're referring to the actual live data of the business. Learn more on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
The topic for today is a very, very interesting one. It's one I've been tracking for the last 4 or 5 years now. It's sort of a new concept, but really it's more of the culmination of concepts. And the topic is called data orchestration. So what does that mean? It implies obviously lots of instruments, right? We have lots of kinds of data. We have lots of systems out there moving data around. And the way that people have moved data around historically has been largely ETL. Although sometimes you just drop it on a disk and ship it across the country. You can do that too. You can do ELT, which is a sort of newer version of ETL. And that, of course, stands for extract, transform, load. And the extract, load, transform came around, again, about 12 or 15 years ago is when we first started seeing that. And that happened in part because you can preserve all the context to the data. A lot of people don't realize that in the data world, if you look at like data warehousing and business intelligence, in the old days, 25 years ago, we had to strip out all that context to get the data through the thin pipes to get processed by this relatively slow processors, and storage was expensive, so you didn't want to keep everything. Well, most of that has changed now, and the cloud is a big, big part of it. We're going to talk to some experts, about Snowflake today. Of course, Snowflake DB, the cloud data warehouse that's really taking off. I mean, it's amazing how much traction those folks have gotten in a fairly short period of time. We did a webinar with them back around 2015 or 16 when they were starting, and my, how things have changed. But they're not the only one. There are lots of other data warehouses in the cloud. Of course, on-prem is kind of here to stay. And the bottom line is people are going to want to move data from one place to another, or at least give access to data where it is. And we're going to talk all about that with our guests today. We have Taylor McGrath joining us. We have Divyansh Saini, and we also have Chris Sachs. And we're going to learn about their different companies. Taylor is with Rivery, and Divyansh is from Houseware, and Chris is with a company called Swim, all of them doing really interesting things. So Taylor, ladies first, tell us a bit about yourself and what you folks are doing in the space of data orchestration.
Hi, hi everyone. I'm Taylor McGrath. I lead what we call our data labs group at Rivery. So that's our internal data stack, as well as a lot of our product evangelism and data advisory. At Rivery, we are a SaaS ELT platform. So that covers areas of the data stack like ingestion, transformation, whether that's SQL or Python, or transforming at the source of the files in a data lake itself, as well as being able to activate your data or send data via reverse ETL back into source systems. And so data orchestration is a huge part of what we do in terms of simplifying how we can orchestrate things, as well as being flexible to orchestrate via APIs, easily consumable APIs with other best of breed parts of the data stack.
Yeah, and I think you folks came along with a pretty clear vision to help really kind of harmonize and align these environments, right? Because especially if you start working with bigger companies, they're going to have 3 to 7 ETL tools. They're going to have 2 to 7 data warehouses, lots of data marts. They're going to have code that they write, Python perhaps. They're going to have lots of different things going on. And that's a real mess for anyone who wants to govern what's happening. It's a mess for data quality. It's a mess for organizational change. But it's the reality of most scenarios out there in the real world. Maybe could you talk about how you can help with your technology to make sense of all that and start to kind of rein in the cats, let's say?
Yeah, definitely. I think, a big piece, especially with bigger companies, is connecting the dots, so to speak. And I think a metric we like to use is like time to new use case, basically. So how scalable is your stack in terms of getting to the point where you can onboard a new use case that provides business value. And so it's really all of the pieces there in terms of if you need new data, you need to enrich, transform your data, maybe make it operational by sending it back to some other system, and then orchestrate that whole piece. What is the simplicity of that? But flexibility, I think, is huge in terms of, especially with these bigger companies that have lots of incumbent systems where they're truly integrated and part of their day-to-day operation. It's not necessarily something that you sunset in a month and 2 months, even a year or two. It's being able to integrate, be flexible enough to work with existing incumbent systems while also providing value quickly. So I think, sorry, my lights just turned off in here.
That's all right. So stranger things are happening over there. It's okay.
Yeah, exactly.
Exactly. You brought up a couple really good points here. I love this time to next use case as a metric. That's brilliant, because that's what really matters to the business, right? Is look, you come up with an idea, you want to solve some problem. All right, let's get the team together. Let's find the data. What kind of algorithms can we throw at it to ascertain what's happening, to make some prediction, for example, or to classify, to organize, whatever it is. And then you set about doing it. Well, how long does it take you to get that done and get on to the next use case? That's a pretty clear metric to me. Who came up with that one?
Oh man, some genius on our marketing team for sure. But yeah.
That's good. Well, you also mentioned reverse ETL, which I'm seeing a lot about these days, and it's kind of funny because it's like, I guess it is reverse, but there are lots of questions in the marketplace. Well, why wouldn't I just use my existing ETL tool or ELT tool to send things back the other way? And I think the answer to that question lies in the complexity of the target systems. I'm just guessing here, but and also in the capacity or the throughput that these technologies have, right? Because you can have technology that's very good at doing one thing, not so good at doing something else. So tell us a bit about this reverse ETL, which makes every last bit of sense in the world to me, because now you're taking information from the warehouse, for example, and feeding it back into your operational systems, your marketing system, Salesforce, whatever it is, HR. That's like, okay, that's what we should be doing, right? Tell us a bit about that.
Yeah, I think that it's a really hot topic, I'll say. I think more and more we're going to see a drive towards kind of mixing analytical with operational. I think it's inevitable, especially with kind of these best of breed cloud data warehouses that are being more and more tuned to accommodate both. We're going to see a lot of products built on top of the warehouse from inception. To be operational. So I think reverse ETL is huge there. And I think you'll hear reverse ETL, you'll hear data activation. It's really, the goal is to enable our end users, our business users, to make these data-driven decisions in their operational tool. You'll hear things like the dashboard is dead, yada, yada. We need to actually have the information, whether it's a recommendation or it's you need to act on this way, in our operational platforms like a CRM tool or an EDP tool, et cetera, like where the action actually takes place. So I think that was the dawn of reverse ETL and those types of use cases. And I think it will be, being very transparent, it will be a struggle, a battle between is reverse ETL always going to be data warehouse first? Or, and I'm sure Chris can speak on this too, is it going to be something that is streaming worthy, I'll say? Is it truly operational? Are we going to send these direct from source to target operational system, with some like real-time layer that does those transformations? Or is it something where we're basically going to take the opinion that our data warehouse is that layer? So I think we'll see both things, I think, grow. But currently, I guess Rivery as a product, we're very ELT, we're very data warehouse first, in terms of we're using the data warehouse as a source for that reverse ETL. But yes, my biased, trying to be unbiased opinion is that I think for different use cases, they're both very relevant. And I think we'll grow, like we're going down the road of operational, and I think it will continue that way.
Okay, that sounds good. And you gave me segues for both guests here. That was brilliant.
Yeah.
Maybe I'll choose Divyansh, since what Chris is going to talk about, I think is really very, very interesting in a different way. But let's talk to Divyansh, since we have a nice segue there on cloud data warehousing and Snowflake in particular. And I just came back from the Snowflake Summit, which was amazing, I have to say. And guess what those folks are talking about? They're talking about, I think they call it Unistore. They're talking about building apps, bringing the code to the data warehouse, data in the data warehouse. Well, as I wrote an article about this, I thought to myself, as a business person, you're like, well, can't Azure host my applications, and can I stand up a database in there? And the answer is yes, you can, you absolutely can. This, though, is a bit of a departure, and some savvy analysts think it's a pretty clever thing for Snowflake to do, because Snowflake has historically been the data warehouse. So they have a very clean partner strategy. We manage the data, you do the analysis, build apps on top of it. Very clean. That's a brilliant way to go in terms of partner strategy, I have to say. I think it's why they're doing so well, at least one reason. But building in this environment, it brings some interesting challenges, and ideally it brings some real power too. But Divyansh, why don't you tell us a bit about what you folks are doing? Because I find it very interesting. And let me characterize it, tell me if I get it wrong. You are giving visibility into what you call metrics in Snowflake, and then allowing business people to quickly grab these metrics and pull together views of the business, which is what analysis is all about, really. Tell us a bit about that.
Absolutely, Eric. And I think you mentioned Snowflake. Snowflake is such a core part of our strategy as well, and how we think about it, Houseware. So I'm one of the co-founders of Houseware. The way we see ourselves is as the data apps company. What we are seeing a lot more happen with trends around data orchestration, data activation, as Taylor mentioned, is that people don't just want to be using analytical data for analysis. They also want to be using it for more operational use cases, more data activation use cases, and which is where all of this data now goes and resides in the data warehouse. But this is where it goes and really dies if, let's say, it is not really used for anything apart from dashboarding and reporting. So which is where Houseware comes in, allows users inside functions like sales, customer success, marketing, a product to really create these applications on top of it as internal applications inside their organization, which are really combining the best of the breed of visualizations, data activation into one single plane for them to really talk to their users and actually sort of take actions on top of it. So Houseware essentially really started with a very simple question to ourselves, is that what would it take for us to flip the value of the data warehouse, which has largely been an engineering and a data team's resource, to the people on the other side of the table who are essentially revenue function oriented. And one of the core differences that we realize in the cultural differences that we realize between the users on the data team and the users on the revenue function is that the language itself is very different. The data team is always talking about tables, rows, columns, schemas, models, whereas your revenue function, people inside sales, product, customer success, are always talking about metrics. Now, metrics are these first-class citizens that Houseware really enables these users, as you mentioned, Eric, to look into, to go deeper into, and this is where the real analysis really happens.
Yeah, that makes a lot of sense to me, and it makes it very business friendly, right? What you want is for these things to be sort of like under the hood technology. You don't need your business people to understand exactly how the ELT works or the ETL works. You don't need them to be masters of SQL. But you want the business people to know their business and what's happening in the business and be able to pull from this trusted source, the data warehouse, to get the numbers to wrap their head around something. And then you're actually enabling the building of apps around that as well, not just dashboards and views, right? But this is another huge trend I'm seeing. We'll talk to Chris Sachs about this next in the next segment, but there is going to be an entirely new generation of apps that are coming out. They will be data and analytics driven apps. They'll be very focused on the business. And it's really the next generation of business functionality. What do you think, Divyansh?
Yeah, for sure. And I think the entire world of data is up for grabs, as I keep repeating time and again. And the reason why I say this is because I think in the last half a decade or so, we have seen so much great technology come and being provisioned to data teams inside an organization. So there is ETL, there is reverse ETL, there is the data warehouses itself. You have simple machine learning tools, you have complex machine learning tools, you have the modern day notebooks of the world. So the data team is pretty much, they have their arsenal full, right? But the eventual goal always, if we go back to the basics and the fundamentals, the eventual goal was to actually optimize for the processes and the outcomes inside an organization, increase the revenue. And which is where there's a very important need for a company to come in and a tool to come in and really consolidate all of this efforts that has gone into the technological part of fueling the data team into creating an experience which is super important for these end users. And I think from an infra landscape, if you see like the Snowflake strategy, what they are going after, Snowflake Summit 2022 made it super clear from Snowflake's perspective that applications is a core part of their strategy. They also realize this need that the cloud data warehouse, calling it the data cloud now, is super essential, because you're not just going to be calling this $100,000 spend on a data warehouse to be just as a data spend. You have to sort of also talk about like the business value that you're giving to your end users inside the revenue function, and which is where things like Unistore, things like the native apps framework essentially brings, to Taylor's point, like brings the operational data along with the analytics data into one single plane, which allows companies like us to really flourish on top of it.
All things data orchestration. Now we're going to talk about some real-time data and some data movement and edge computing and all kind of fun stuff. And I'm reminded of another fun quote when I was interviewing Dr. Michael Stonebreaker on this show about, 10 years ago, I want to say, maybe 12 years ago. He had a great quote where he said, and this is the godfather of the modern database, or at least the Postgres database. He said, 90% of code should just be thrown away. And his point was that the code running all these applications from way back when was designed in a much different world, where you had to wait for spinning disk, for example, where you had to wait for slow clock speeds or whatever it is. Like in the inside, the workings of the machines, the operating systems they compiled for, well, so much of that stuff has changed, certainly in the cloud. And then the edge is almost like cloud 2.0 if you break it all down like that. But next up, we have a fascinating character, Chris Sachs from Swim. Tell us a bit about yourself and where this all came from.
Thanks, Eric. Good to be with you. Yeah, I'm the co-founder and CTO of Swim. And at Swim, we've built a streaming application platform. And the idea is that we need a lot more than just analytics and processing data and putting it in a database. We want to build autonomous systems that can consuming streaming data at high rates, put it together and act on it in real time, and to be able to basically run the whole stack, compress the whole stack from ETL to data orchestration to running general purpose business logic, to taking autonomous action and providing visualizations and observability for end users, sort of all is sort of quickly and directly as possible in a single vertically integrated stack. And so that's sort of Swim in a nutshell. It's trying to pull the rope as tight as possible. What's the fastest, most direct way that we can analyze and understand and compute on data to do useful stuff with it, sort of at the speed of reality, if you will.
Yeah, and you talk about how you started as an edge first company, and out at the edge, again, think about design points, right? And when you're working with trying to solve something at the edge, well, you have to be very lean. It's like the old days of programming, and there's this concept of code bloat, that as processors got faster, developers could get lazier, basically, and just write a whole bunch of code to do something instead of writing it nice and tight, which is what it really always should be, right? I mean, ideally, you want your code as tight as possible. You want as few functions as possible to get the job done. And so you all cut your teeth out the edge, which I think taught you a lot of lessons, right? Tell us about that.
Yeah, so to run at the edge, so Swim we really come at this data orchestration picture from a different angle. Swim started as sort of an IoT automation platform where we would run actually distributed control logic out at the edge, sort of controlling smart lights and cameras. And kind of by necessity, we had to integrate a lot of the stack, just because the devices are more constrained, but also because you're very latency sensitive when you're out. That's the whole purpose of running at the edge is to reduce latency. And really, when you're dealing with control and automation, you really need to be coherent with the real world. If nobody wants a light to turn on, after they've left the room, And when you go to the cloud and in larger automation systems, you need to be real time. You don't want to, if you have a network that goes down and you decide you want to restart a router, you don't want to restart that router an hour later, when the thing's already started working again. So we had to compress the stack so that we could run in the edge. And it turns out that there's a lot of incidental benefits of compressing the stack that help elsewhere.
Yeah, and I heard you describe early in one of our calls the other day, how you viewed the world, and you really did think through the entire end-to-end process and how much things have changed, and you realized, look, we need to build something from the ground up to reinvent the wheels, as I'd like to say, because for certain solutions at scale, you can't just optimize one piece. And you were joking about how so much of the data world winds up becoming de facto band-aids for the mistakes we made last time. And how many band-aids can you wrap around the cup before it just leaks all out and you lose all your data, you lose all your water, and you lose all your money. And so you had a very unique approach, I think, to the whole solution here, and you re-architected. Tell us about that sort of vertical stack and what those components are and how it works.
Yeah, and it's worth. So you really have to get down to brass tacks to work in real time, right? Because sort of anything that you're only going to be as fast as the slowest component.
Right.
And it's also worth keeping in mind. CPUs are much faster than networks. A lot of the data ecosystem, it's very federated, right? You have lots of middleware components. You have databases and message brokers and sort of job managers and application servers, and they're all connected by networks, which run at sort of millisecond latencies. But CPUs work at nanosecond latencies, and that's like 6 orders of magnitude faster. And so if you want to run sort of at the speed of data, if you want to actually sort of run business logic, as fast as the data is coming in, you have to keep everything local on hand. It's like paying 1,000,000% tax to go and query a database. And we're talking about data orchestration here, right? So we're talking about many different sources of data coming in, and they're coming in at different times. And, for some of our larger clients, they're dealing with 5 to 10 million events per second. And data doesn't have much meaning on its own, right? As you mentioned earlier, Eric, you really need context to make sense of it. And so the key is to be stateful and streaming throughout the stack, and that's what we've done at Swim, is build the whole stack to be stateful so it doesn't forget what it's doing, and to do everything in stream.
And I'm glad you mentioned that. This is going to be a good roundtable topic. So for the benefit of our virtual audience out there, state is a very, very important concept in programming. I try to come up with examples to explain. Think about when you're shopping online and you're browsing, you select a few things, you put them in your cart. That's part of the state. So the state recognizes who you are and the fact that you have these items in your cart. And then you want to go check out. So now you go to a different state. Now I'm in the checkout mode and I want to make sure it's all correct and give it my data, et cetera. Well, the interwebs at large here, if you look at a lot of the tremendous innovations that have happened in the past 10, 15 years, they are all built around a stateless view of the world because they want it to be able to be scalable. So you hear all about Kubernetes. We talk about Kubernetes all the time in the show. It's absolutely fascinating technology. It's brilliant what these folks at Google came up with, but it's all stateless. And so state then has to be stored somewhere else, in either a database or some system of record. And that can get a little loosey-goosey. It can get kind of hard to manage if things fall apart. It can get kind of hard to put back together. I mean, there are just challenges associated with that. And what Chris is talking about here is they took an approach to basically circumvent that huge chasm, which everyone else has to jump over now. Is that about right, Chris?
Yeah, and it's worth pointing out, like, we're having a stateful conversation right now, right? I remember what I said a minute ago, and you remember what you said, and to put in perspective, what a stateless system is like, is imagine after every question you ask me, Eric, I had to go walk 60 miles to check my notes, which is query a database. Remember, it's 6 orders of magnitude longer than it takes a CPU to think. So instead of sort of 1 second for me to formulate my thought, imagine it takes 1,000,000 seconds while I go and, I check my notes, then I come back and I give you a response, but now you've forgotten what you had said, so you have to go and check your notes and come back. That's
funny.
But that's actually how most software works, and that's why nothing is real time, because everybody, you check your notes, you do one thing, and then you forget, and you start all over, and you just can never get to real time in that way. But it's not because of anything fundamental; it's because of sort of the historical happenstance of the kinds of applications we used to build, and what the industry is trying to do now is different, and it calls for a different approach.
Well, and so what's happening here in a second, we'll bring in our other guests for the roundtable, but you have so much innovation all up and down the stack right now. I mean, really, you think about it, the data persistence side, streaming data, for example. Kafka came out of LinkedIn. It's now run by Confluent. But even Kafka, to Chris's point, persists to spinning disk, if I'm not mistaken. I think it still does. So here, that's not really real time. You're persisting it somewhere and then accessing it from the database. And this is how things have been for years and years and years. I mean, you could almost say we're coming back all the way around to a situation kind of like the mainframe. Like that's what the mainframe was to a large extent, and you bought little bits of time from the mainframe. I can't remember what they called that. But the point is, we've seen so much innovation up and down the stack in networking and processors, the hardware, the software, all these devices. And you think about it takes time to build software. It takes time to build something. So if you want to build what Chris and his team have done at Swim, you have to have the gumption to do so and really take the time and effort to build this thing correctly. And then, of course, you have a target audience. And you folks are very good in telco, right, where you have tremendous amounts of data, and it's really important to know what's happening now when calls are dropped and things don't work well. So you're kind of cutting your teeth in that world, but there are use cases across the board, right?
Yeah, I mean, if you look at the broad industry trends, like the time cycles are getting faster and faster across the board. Telcos, it's particularly acute. But even in, if you're like a shopping application, and you have pickers going to a store. If a store runs out of a product, you want to be able to redirect them on the fly. Or you might be making a drone delivery. You don't want to have to, and maybe in flight you decide to, you need to redirect that drone. And so the trend is towards, faster and faster, time cycles. And again, if in the traditional approach, it gets sort of exponentially more expensive to do real time because you're always polling these systems. I like to compare it to like accelerating a proton to the speed of light. Like it's never going to happen. It takes infinite energy, because you keep having to query and you keep having to ask. But if you build the system to work like a photon, you just naturally, if you naturally sort of do your compute as the data arrives and you remember the context you need, you're able to, you can't help but operate in real time. And you reset that cost curve and you reset the complexity function in the process because you've sort of, stripped out the layers of bandages that have sort of, a lot of the complexity in the data space are really trying to work around this fact that we're stateless. You have that's caching servers and all of this that's really there, to work around this sort of core assumption that no longer applies.